Namaskar. Namaskar. I welcome you all to our channel Mind Mapping. Our handle at the rate MNMP. If you like our videos, I would like to appeal you, please subscribe to our channel and share to your friends for wide dissemination. So let us come to our topic. Today we have taken a question from your chapter carbon compound. Some student they have appealed me, they have requested me to teach this topic, to teach the concepts of this topic. And this topic seems hard for some students, not for all. But this is very enjoyable topic from academic point of view and from examination point of view. For class 10 examination, for the upcoming examination 2025, we have taken an example. We have taken a question that we have developed, and we have not borrowed, and we have not got this question from any source. The question is the molecular formula of a carbon compound is C6H12, and this is the key point. From that, we have asked three questions carrying 1 mark each, means that question carries 3 marks. Write the name of the compound, that you have to write the name. Draw its structure. So you have to graphic structure, you have to draw. Or count and write the number of sharing bonds or covalent bonds in the compound. Only three things, and three means actually stimulus bound answer. So let's discuss. And our objective not to give the answer, but you can get the answer from our discussion. And let us actually make your concept clear. C6H12. Let us start from this. What is given? That molecular formula C6H12. So note it here. So how many carbon atoms? 6. How many hydrogen atoms? 12. So we have mentioned C6H12. It denotes there are 6 carbon atoms in one molecule and 12 hydrogen atoms. Okay. So first step is clear perhaps. Come to our second, arrangements. Now look at this, is very important. Now you see we have arranged 1, 2, 3, 4, 5, 6. 6 carbon atoms in a straight chain. Okay. Now you see this is the first kind of arrangement, and the second type of arrangement, that is called branch chain. You see 1, 2, 3, 4, and here you 2 branches. Like a tree, you see 2 branches. Now you see 1, 2, 3, 4, 5, 6. You see we have mentioned here C6 and also here C6. Okay. So another structure we have mentioned here. Another structure we have mentioned here. You see 6 carbon atoms in shape of a ring, that is called ring chain. So this is the first type, straight chain, and this is the second type, branch chain, and this is the third type, that is called ring chain. So only arrangement of carbon atoms. Okay. And here is a question for you. The carbon has the ability to form bond with other carbon atoms. That is called self-linking or self-bonding ability. Ability to link bond with other carbon atoms. And that property the carbon has. And this property is called catenation. The ability to form bond with other carbon atoms. You see 6 carbon atoms. Now they have formed, they are joined, they are connected. Okay, so this is one type of connection, one type of chain, that is called straight chain. This is called branch chain, and this is called ring chain. Okay, so now come to carbon and hydrogen. Okay, you see, hydrogen is the best friend of carbon. So many other friends are there, but hydrogen is the best friend. Now let us actually combine the carbon with hydrogen to satisfy their outermost shell, so that carbon will be, will attain the inert gas configuration, and hydrogen also at the same time will get means the configuration of helium, that is inert gas and our gas. So both will be stable. So that can be done by whatever bond, that is called covalent bond. Okay. So you see, we have mentioned here hydrogen is the best friend. So carbon and hydrogen sharing means carbon and hydrogen, they form, they establish covalent bonds, and the compound having only carbon and hydrogen, these compounds are called hydrocarbons, and it comes under carbon compounds. These are called hydrocarbons. Okay, hydrocarbons. This is very important. Okay. That compound contain two elements, that is carbon and hydrogen. They are called hydrocarbons. Okay. So let us point number 3, carbon and hydrogen sharing. Now you see 1, 2, 3, 4, 5, 6. Okay. So let us count. So carbon outermost shell contains 4 electrons because atomic number is 6. So 2 in K cell and 4 in L cell. But carbon requires another 4 electrons to be stable. But mind it, carbon cannot lose 4 electrons, or carbon cannot gain 4 electrons. There are two shortcomings, there are two difficulties, there are two problems for carbon atoms. So what the carbon atom does? Carbon atom shares, means establishes covalent bonds between other monovalent elements, and here sharing bond with the hydrogen atoms. So let us count. So here carbon 1 and hydrogen 1, 2 to 4 to 6 and 8. Carbon satisfied. And hydrogen requires only 1. And it is shared by carbon. So carbon 2, hydrogen 2, 2, 2. So all are satisfied. No one is dissatisfied. Come to this. First carbon atom, this section is over. Okay, come to the second section. So 2 to 4 to 6, 8. Now second carbon is happy, it's satisfied. And hydrogen 2, hydrogen 2. And two hydrogen atoms, they are also satisfied. Similarly verify. So 2 to 4 to 6 and 8. Okay. Then 2, 2. 2 to 4 to 6 and 8. Okay. Then 2 and 2. Okay. 2 to 4 to 6 and 8. Okay. So 2 and 2. And here 2 to 4 to 6 and 8. And here 2, here 2, here 2, here 2. Okay. So carbon you see 2 to 4 to 6 and 8. Now all 6 carbon atoms, all 6 carbon atoms. And let us count how many hydrogen atoms. So you 3 to 5, 7, 9, 11, 14. So you see 6 C6 H14. So here is a compound. That molecular formula is C6H14 as per our straight chain. Okay. So, but actually our question is C6H12, but here we got C6H14. But actually here 2 hydrogen atoms is less. But actually let us consider the second arrangement. Second arrangement, let us see what happens here. Now you see 2 to 4 to 6, 8, and here 2, 2, 2. Satisfied? Okay. Come to the second. 2 to 4 to 6 and 8. Okay. 2 and 2. 2 to 4 to 6 and 8. Okay. 2 and 2. This okay. So this carbon 2 to 4 to 6 and 8, it is also okay. Okay. This hydrogen atom 2. And now see, so this carbon atom 2 to 4 to 6 and 8. Okay. So here 2, 2, 2. So here carbon atom 2 to 4 to 6 and 8. And here 2 hydrogen atom 2 and 2. All carbon atoms, 6 carbon atoms. And how many hydrogen atoms? Let us count. There might be some differences, there might be some discrepancies. Count it. 3 to 5 to 7, 7 plus 1, 8, 8, 3, 11, 11 plus 3, 14. Now correct? You see, in both the cases, we found that is C6H14 and C6H14. But what difference do you observe? Do you notice? Do you find? Only molecular formula same. You see C6H12, C6H14, C6H14. No difference. But what is the difference? What's the difference? The difference in structural arrangement. So that we have mentioned here, arrangement. Here the straight chain and here branch chain. And now the two arrangements were called isomers. Isomers of that compound. Same molecular formula but different atomic, different structure. Okay, different structural arrangement, different structure. Okay. Now we presented this is called isomer. Two isomer. No, not this is the isomer of this. Okay. So we shall actually name it. Come to the actual name. Look at here. Here is the ring chain of 6 carbon atoms. You count 1, 2, 3, 4, 5, 6. So they are in form of a ring. Now let us count whether they are satisfied or not as per their electronic configuration. So now you see 2 to 4 to 6 and 8 satisfied, and hydrogen 2, 2. And this carbon atom you see 2 to 4 to 6 and 8 satisfied, 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 2 and 2, 4 to 6 and 8 satisfied. So all 6 carbon atoms and all hydrogen atoms. How many hydrogen atoms? Let us count. We cannot say actually. Here we got actually 14. Here we got 14. In case of a ring chain, let us count. So you see, let us start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. 6 carbon atom. Each carbon atom makes bond with 2 hydrogen atoms. So naturally C6H12. Now we got the clue, and here is our answer. Okay, here is our answer C6H12. Okay, so then we shall discuss what's its name. Okay, we shall discuss. So another thing actually, just we forgot, count the number of bonds. Now we recorded, we observed or we noticed the differences. Hydrogen 14 in case of straight chain, hydrogen atoms 14 in case of branch chain, and here hydrogen atom 2 less, that is 12 in case of ring chain, and that compound structure is definitely in form of a ring chain. Okay, so then we shall actually come to the conclusion what name we should assign and by what name we shall call it. Okay, and its nomenclature we shall discuss. Okay, and how many actually bonds, sharing bonds or covalent bonds, not electrovalent, covalent bonds. So you see 3, 4, 6, 7, 9, 10, 12, 13, 15, 16, 16, 3, 19, 19 bonds. And here 3, 4, 6, 7, 9, 10, 11, 12, 13, 13, 16 and 19, 19, 19 bonds. Okay. So in both the cases, molecular formula same and the number of bonds also same. But what is the difference? Only arrangement, structural arrangement is different. That is called isomer. Okay. We shall discuss in another video. So here you see, let us count the number of bonds. Okay. So 1, 2, 3, 4. 3, 4. 1, 2, 3. Sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. Now you see 18. Okay. So one bond is short. Why? That question will be why. Due to this ring structure. Due to this ring structure, now you count only 1, 2, 3, 4, 5, 6. Okay, 6. Then 6 to 8, 8 to 10, 12, 14, 14 to 16, 14 to 16, 16 to 18. Now you look at the difference. So in ring chain, we find some differences. In differences in number of hydrogen atoms, even number of sharing or covalent bonds. Now come to our fourth. The formula, that is alkane, hydrocarbons, there are three kinds. One is alkane and second one is alkene and third one is alkyne. But remember, for alkane, the formula is CnH2n plus 2 and H is a natural number, and for alkane it begins right from 1, 2, 3, 4. Okay. So apply this formula. Here how many carbon atoms? 6. So N is 6. So C6 H2N, 2 into 6 plus 4, 2. So 12 plus 2, 6, 6, H14. So it is called alkane, ANE, alkane. And you 6 is hexa, so it is called hexane. It is called hexane. Okay. And this is hexane of trade chain. And this is also hexane. This is also hexane, but branch chain. Okay. C6 H12, same formula you see, Cn H2n plus 2, C6 H14, no difference. But due to the structural arrangement, they are called isomers, isomers of hexene. Isomers of hexene, not hexene, but hexane. Okay, but here, what name actually you please think, you please tell me, what should we call this molecule? Yes, anyone? No answer. So it is called cyclohexane. In cyclic order, this is called cyclohexane. Okay. So this is cyclohexane. In case of cyclohexane, we find some differences. You see differences in the number of hydrogen atoms and difference in the sharing or covalent bonds. Now over, hope you have understood. The name, it is called hexane and it is called isomer of hexane and it is called cyclohexane. We have already mentioned. Okay. These are the concepts. Please go through one by one. Then bonding of carbon atoms. You see here in the ring chain, you see 6 carbon atoms. That is called single bond between carbon atoms. Single bond. Okay. When single bond between the carbon atoms and these compounds are called saturated hydrocarbons. Remember, saturated hydrocarbons. And here also you see single bond, single bond, single bond, single bond between carbon atoms, that is called saturated hydrocarbons. So this is also saturated, hexane is saturated, and isomer of hexane, it is also saturated. But in case of ring, you see single bond, it is also saturated. You see no question of double bond, only single bond between the carbon atoms. You see. So here is a question, whether the cyclohexane is saturated or unsaturated. Prove that it is saturated because you see single bond between the carbon atoms. Okay, so it is also saturated hydrocarbon, but molecular formula is different. Arrangement is in the cyclic order. It's called cyclohexane. Similarly, we can prepare butane, cyclobutane, propane, cyclopropane. We can develop and we can write, and the question may be set. And then another thing, come to, we discussed, actually I told you, actually there are three kinds of hydrocarbons. One is saturated, another two they are unsaturated. In what form? You see, they are called, this is called, second one is alkene, and formula is CnH2n. C1, sorry, CnH2n. Okay, and if C is 1, H will be 2. But mind it, here is a question. For this alkene starts from 2 carbon atoms. So the first molecule that contain 2 carbon atoms. So here N begins from 2, 3, 4. We have also mentioned also 2, 3, 4. Okay, and it has been clearly mentioned in your textbook. And methane is a saturated hydrocarbon, but we cannot actually prepare its methane using 1 carbon atom. So here is a question for preparation of alkene, means unsaturated hydrocarbon. We have to follow the formula Cn. This is very important. CnH2n. This formula is given in your textbook, but my dear students, you please mention, you please actually remember this formula, that is alkane is not given, and another is alkyne, that is also not given in your textbook. Here, in case of alkene, there may be one double bond. Sorry, there may be one or more double bonds. Here you see one double bond between 2 carbon atoms. Okay, or more double bonds maybe, but one and more double bonds, that is called alkene unsaturated double bonds. You see unsaturated hydrocarbons, and there must be 2 carbon atoms. Okay, you see 2 to 4 to 6 and 8. So this carbon atom is satisfied. Now you see 2 to 4 to 6 and 8. This carbon atom is satisfied. And hydrogen 2, 2, hydrogen 2, 2. Hydrogen, they are the friends. Na? By sharing, all are satisfied. This is called unsaturated hydrocarbon. And it begins, end begin from 2, not from 1. That is a question. Okay. So alkyne, you see, and here you see, it also begins from 2, 3, 4. Alkyne, the formula is CnH2n minus 2. So you see C2H4. C2H4, we have mentioned here C2H4, that is called ethene. From ethane, that is called ethene. And C2H2, you see, C2H2. Now you put N2, H2 and H4 minus 2 or C2H2. C2H2, that is called ethine. Now you see one triple bond between 2 carbon atoms. One or more triple bonds between the carbon atom, 2 carbon atoms, that these compounds are called unsaturated hydrocarbons, triple bonds. You see 2 to 4 to 6 and 8 to 8. Now this carbon satisfied, 2 to 4 to 6 and 2, this satisfied. Okay, and hydrogen 2, 2, and this is called ethine. And two big, actually minimum 2 carbon atoms. So it begins from 2, 3. Here n is 2, 3, 4 like this, but in case of alkane, that is n is right from 1, 2, 3, 4 like this. If you n is 1, that will be n1, that will be methane. You see Cn H2n plus 2, and if C is 1, H will be 2 into 2, 2 plus 2, 4. Well, this is CH4. This is methane. But In case of ethane, that is C2H6, ethane. But ethene, you see, C2H4. Sorry, ethene, C2H4, yes, C2H4. Ethyne, C2H2. But it is in formula of, you see, CN, cyclohexane, CnH2n, C6H2n, 2 into 6, 12. But it is not, although it is according to the formula of alkene, but it is not unsaturated. Why? Because there is no double bond between the carbon atoms. The question might be acting in this way. This is the trick. You see, though the formula satisfies the unsaturated alkene, that is CnH2n, you apply C6H2 into 6 H12. So we can say that is called hexane, that is called hexene. No, it is called cyclohexane. It is saturated because no double bond between the carbon atoms. Now we got the answer. Write the name of the compound, cyclohexane, simple. Draw its structure, structure is drawn for you. Count and write the number of sharing bonds in the compound, you see, 18. Only 3 words. Means stimulus bound, very specific. These are called technical questions. This is the basic concept about isomer and cyclohexane. Okay, and in our next video we shall discuss about the properties of carbon, and due to the properties of catenation, carbon forms long chain of carbon compounds including your hydrocarbons. So don't be confused. In the compound where only carbon and hydrogen are present, carbon and hydrogen atoms are present, these compounds are called hydrocarbons. And there are three kinds of hydrocarbons. One is alkane, another is alkene, another is alkyne. CnH2n plus 2, and we have mentioned here the formula, and the formula is here, and here CnH2n, that is for alkene. For double bond, alkyne CnH2n minus 2, and these two formula, this is given in your textbook, and the first one and the second one, for alkane and alkyne, these two formulae have not been mentioned in your textbook. So we have discussed. Hope you have understood our basic concept and our purpose. In our next video, we shall present the properties of carbon. Thank you so much, and I solicit your considered views and opinion, and if you like, you may subscribe and share this video to extend the benefit for others. Thank you.